Thank you so much for coming early in the morning. Some of you have skipped coffee as well. So I appreciate your coming and to this session on ArcGIS API for Python for analysts and data scientists. So I know it's a wide spectrum. It's a continuum from whether you're an analyst or a data scientist. So how many of you consider yourself as an analyst? Okay, pretty awesome. A lot of you. How many of you consider yourself as a data scientist? Well, analysts are also, doing data science, but the tools are sometimes different. And, the hope is that when you go through this session, you'll see how, for the analyst, how you can use the Python API and get into the data science realm. And how many of you know about ArcGIS API for Python and how it's different from ArcPy? Okay, how many don't know that how it's different from ArcPy? Okay, so just to clarify that, we've got two Python APIs primarily when doing analysis with ArcGIS, and there's the ArcGIS API for Python, which works with your WebGIS, which works with ArcGIS Enterprise or ArcGIS Online. So the data sets that you're working with are layers or services, and the analysis runs on the server with Enterprise or Online. And then there's ArcPy, which is an older library. It's been there for long, a lot of capabilities for doing powerful analysis on your desktop or laptop. So some introductions. My name is Rohit Singh. I am one of the developers on the Python API, and I'm focused more on the analysis and the data science side. Joining me is Alberto. So Alberto, please introduce yourself.
Sure. I'm Alberto Nieto. I'm a solution engineer, and I'm based in the Washington, D.C. office.
Great. So let's just get started. And like I was saying, there's a wide continuum that goes from analysts to data scientists and then developers who are also doing analysis. And analysts typically are focused more on getting the insight, getting the reasons why something is happening or predicting what might happen. And they typically use tools. Data scientists, on the other hand, they typically, these days they use notebooks, they use Python. And of course, programmers, they get paid for writing code. What's interesting was that how everyone gets paid. This is a slide I borrowed from a PyCon session in New Delhi. And, what I found interesting was analysts get paid for the insight they produce. Data scientists get paid for the code that produces insight. And of course, programmers get paid for code. But what's the common binding factor among all of them is Python. So whether you're an analyst, Python is such a simple language that you can read it, you could modify some Python code. Some of you are already automating your workflows using Python and ArcPy. And making them repetitive. As a programmer too, Python is a great language that scales up and lets you do complex tasks. So why is Python getting so popular for data science? Right now, it's the #1 language. On Stack Overflow, actually, it even overtook all other languages, and it's the most widely used language altogether. But when compared with the data science languages like R used to, it's still at, among academic circles, it's still at the top. But in general, Python has now overtaken it when you take the whole spectrum. You get a lot of productivity with Python. It's a great glue language, lets you call in code from different libraries, different, Fortran even. And it's also a two-language problem, which is if you were a data scientist and you were doing, your work in MATLAB, for example, or some of these domain-specific languages, you did your analysis once, and when you had to put it in production, you had to then move to another general-purpose language like Java or C++. But with Python, you can span that entire ecosystem and quickly go from your prototyping, your analysis, and then actually deploy it in production. And of course, Python has a great ecosystem of libraries and an awesome community. This is Introduction to Data Science course at Berkeley. And all students, it's it had the largest enrollment. There are like over 1,400 students signed up. And they're from all disciplines, so everyone is learning Python when it comes to analysis of data. So what are the different types of analysis that you can do with your WebGIS that are now accessible through the Python API? Well, the official name is ArcGIS API for Python, but we just call it the ArcGIS Python API. You can do spatial analysis, you can perform mapping, and you can do GIS administration as well. We've got some sessions on that. I'm not going to go into the administration and content management. And here on the right, you can see the different modules in the Python API and how you can work with different types of data sets shown in green. You can do the workflows shown in blue. And it also has visualization capabilities, which you typically haven't seen in use with Python, but with notebooks, you can actually get maps inside of your notebook, maps and scenes. So we've designed this API so it really works very well with Jupyter Notebook. How many of you know about Jupyter Notebook? So that's awesome, like pretty much everyone. And it's notebooks are now a capability of ArcGIS Enterprise. They have been shipping with 10.7. It's in the second release now with 10.7.1. And now there's a beta coming up for notebooks in online. It's going to be there in online as well. So we've integrated really well with notebooks, and it's a very interactive, immersive experience. You can get maps. You can see the results of your analysis as you work on them. So just a quick, how do you get started? Like you import the GIS module in the ArcGIS namespace. That's our package. And you connect to your WebGIS. Your WebGIS could be, in the first case, it's an ArcGIS online organization. So you can give in your username and password, and you can sign in using all the different types of authentication schemes. Or you could connect to your enterprise GIS, which is on premises or in the cloud. So you typically just connect with one of them, and then you can do content management. You can search for the layers that are there. This is showing how you could search for something related to San Diego, and you get results which are similar to the results you see in the ArcGIS home application, which are visual and interactive. You can take these results, these items, and you can work with them, these layers, and work with them. You can visualize them on a map. So here's an example of that within the notebook. Now let's get into the different analysis engines within the WebGIS and what they let you do. And we are going to start with the spatial analysis, the online spatial analysis tools. And they typically work with feature layers as inputs and outputs. They are in the sub-modules of ArcGIS .features module. And the kinds of things that you can do with them are the same things that you can do with your WebGIS. So if I were to go to my WebGIS, I had it open here. Let's just quickly see that here. Yeah. So the kinds of things that you can do, you would have seen these tools like the standard analysis tools like summarizing data or finding locations, using proximity, like creating buffers. So the most important geoprocessing tools for your workflows, around 37 of them are available with the WebGIS. And you can call them using the ArcGIS features submodule. Some examples of the kind of things that you can do with it, you could summarize data. So you can do aggregate points within polygons, a very basic functionality. Here it's showing how the number of people in each of these relief camps, shown in black, are being aggregated to these counties in Chennai, and how we get the sum of these represented in the orange circles. You can do data enrichment. So sometimes when you're trying to predict some outcomes, you're doing machine learning, you've got some data, but you're, with the data that you have, you might not be able to predict the outcome. It might be that it depends on additional data, like demographic data or business data about those features, what's in their proximity. And ArcGIS has a lot of, it's got the GeoEnrichment capability. and you can add that, that data to your analysis, to your data, use those as additional input features for your predictive analysis. So here I'm adding some analysis variables like the number of people with different kinds of degrees, the household size, the income, number of people with bachelor's degrees. All of these data sets are available for you through GeoEnrichment. It's got tools for proximity analysis, so you can do things like routing or finding the nearest facilities, creating drive time areas. Here's an example of finding routes from a relief center, from a place where the relief supplies are being routed to these relief centers here. You can create buffers, a very basic functionality. You can do overlay analysis, like what falls within those buffers. Once again, the bread and butter tools of GIS are there, and they work with your WebGIS. They're co-located with your online layer, so it's fast. Here is showing some interpolation tools, like interpolating the rainfall from a weather station. So let's switch over to Alberto, who's going to give us a demo of how spatial analysis tools can be used for a workflow.
Excellent. Thank you. Can I go ahead and switch? OK. Has anyone here used ArcGIS notebooks yet? A few people. Awesome. So my first demonstration is going to actually take a look at one of the notebooks that's packaged up with ArcGIS notebooks. As soon as you deploy a notebook server, you get access to this gallery of notebooks that we've worked quite hard to put together. And these are examples that are meant to not only help you learn if you're getting up to speed with Python and with the ArcGIS API for Python, but also if you're trying to replicate some of this analysis, provide your own data, and simply get the outputs for your own domain or your own study area. It's intended to be replicable. And the way you can get access to those, you can actually just create a notebook here at the top. It'll spin up a Docker container, giving you your own notebook. But at the top right, you may notice this samples button. And that'll take you to that gallery of notebooks. There's a lot of examples that look at administration. Those are terribly important. But towards the bottom also, there's these data science and analysis examples. So the example that I'm going to take a look at is one that pertains to site selection, specifically using restaurants in Pittsburgh. So let's take a look at it. And what I mean, a lot of us use Jupyter notebooks, but just a few side notes. I think some of the power of Jupyter notebooks is, first of all, they're really conducive to prototype, right? If you have just a Python file and you're trying to figure out if your code is going to work, and you're testing option A versus option B, and you run the executable or the script, and it doesn't work, it's really tough with like a typical IDE to just prototype one option versus the other. Maybe you can work with checkpoints and troubleshoot that way, but with a notebook, you have these concepts of cells, and you can simply have these different code snippets in one option and not just break your whole sequence, just test one step on one cell, another step in another cell, figure out what works better for you and keep going, right? So that's one aspect of notebooks that I really enjoy. The other aspect is communication. So if you have a process or an analysis that really is conducive to someone making a decision and you're trying to defend it or communicate how you did it, a notebook is a really powerful way to not just kind of communicate the high-level concepts, but also the specifics. If some other data scientist wants to really, help you refine your analysis, they can look at the code, not just the high-level documentation. So in this case, in this example, we're going to take a look at a data set of businesses in Pittsburgh. We're going to filter it down to restaurants. And we're going to pretend that we're going to open up a brand new restaurant in this city. It's a pretty basic example, but it's just meant to kind of give you an introduction into a lot of concepts with the ArcGIS API for Python. And then we're going to use density-based clustering to find restaurant clusters. We're also going to use standard deviational ellipses, which kind of summarize these clusters into zones. And then those zones, we're going to do some additional descriptive statistics to figure out total sales per zone and try to figure out some type of priority and some type of ranking and scoring for each zone so that you could try to just take a first stab at opening up a restaurant in Pittsburgh. Obviously, it would take a lot more than that. But when you open up this example, it really gives you kind of a description of what we're about to do, the steps beginning to end. But my favorite part is this, this kind of sequence that really highlights all the steps 1 through X. Starting with getting the Pittsburgh restaurant data, doing density-based clustering to get your clustered restaurants, then doing standard deviational ellipses to aggregate them up into zones, sales volume aggregation per zone. We're also going to run optimized hotspots in this case because that's one of the score factors. If you're missing anything here that I'm saying, by the way, don't worry, because the idea is that you should open this and at your own pace and read along and learn from it if you want to. And then the final thing is to report it. It shouldn't just live in a notebook. A notebook is very conducive to reading along, but maybe you're a decision maker that doesn't want to get into Python code. I don't know why that would ever happen, but perhaps that's the case. Maybe you export the output out as a service or as a web map or as a story map even. The ArcGIS API for Python can actually configure story maps. How many people have done that? Cool, no. So that's perhaps one of the most useful things I'll say all day. So I won't get too deep into the code here, but I do want to highlight some points. So the first part is there's a lot of imports here. And that's sort of the highlight of what we're doing with the ArcGIS API for Python, with ArcGIS notebooks and Python in general. Python is this rich ecosystem of analytical tools, right? Whether they're in ArcGIS or elsewhere, that's cool. Bring them all along because in some cases we're not going to have the algorithm that you need. So let's go ahead and bring all of those. In this case, we're going to bring NumPy, Pandas, Bokeh for charting, the ArcGIS API for Python, and also ArcPy for a few small parts of this notebook. Over here, I'm just creating a home directory. And actually, the ArcGIS notebook experience gives you this local file space in the notebook server, which is kind of neat. So you can have CSVs, you can have flat files that you upload to this local file space, or feature classes or file geodatabases. And if you happen to work with ArcPy in this case, you can interact with those there. If you happen to work with the ArcGIS API for Python, you can still reference those there. Bring a CSV as a Pandas data frame, or better yet, a spatially enabled data frame. How many people have used that yet? Yes. Okay, one lady right there in the middle. So this is going to be brand new. So right over here, I have a little helper function. This helper function is going to create a map and a histogram. So if I provided a map location and a spatially enabled data frame, it's going to give me a map widget and a histogram of that spatially enabled data frame provided a column. So what I recommend is that you take a look at these helper functions because they're quite useful if you're trying to redo certain things. Like in my case for the Pittsburgh restaurants example, in a lot of cases I just wanted to see a map and a histogram of sales volume. So I kept doing that enough times that I just made it a helper function. So the first main step is to get our data. And you can do the ArcGIS API for Python search for content. In this case, I'm doing gis.content.search, passing it a specific service. With ArcGIS notebooks, you can actually also search for content here using the interface, which is very similar to a web map, if you've ever seen that. And then whenever you search for something here, I'm going to go ahead and actually select one of these. Basically, clicking these buttons will create cells and give you kind of the reference code to that item, which is kind of neat. In this case, I'm going to go ahead and delete those because I already have the code to get our restaurants item. So this is a service that has been published. And I'm going to go ahead and get a layer from that service. And right here, we're going to create our spatially enabled data frame. It looks like a typical Pandas data frame. How many people here use Pandas? Nice, pretty much the whole room. If you use Python and don't use Pandas, that's your homework assignment. Go learn Pandas because it's very powerful. So, and then your second homework assignment is to go look at the spatially enabled data frame. Our documentation for the ArcGIS API for Python has a really good guide on the spatially enabled data frame. If you look at developers.arcgis.com/Python, there's a specific subset there where it says working with the spatially enabled data frame and the introduction for how to work with it, how to get data from a layer, from a feature class, from a series of inputs, or how to export it back out. So let's go back to our example. I got too many tabs open. There we go. It looks like a data frame, but it has a spatial engine behind it. And you can do a lot of things. You can plot a spatially enabled data frame into a map widget, and it'll make a map of all those points, if they're points, or whatever the shape, the geometry that you have there is. I'm also going to briefly create a file geodatabase in our local file space. Notice that I'm using ArcPy in here in the notebook as well. And I want these two things to interact together to solve this problem, ArcPy and the ArcGIS API for Python. So I'm going to convert the restaurant's spatially enabled data frame to a feature class. That's actually one of the most powerful things in the spatially enabled data frame is this ability to just quickly get data in and out of different formats. And right here, I'm just going to confirm that I did create it. So arcpy.exist, that's our output feature class. We got a feature class. Now we're going to explore the data through tables, charts, and maps. So let's go ahead and query just some basic information about our restaurants data. You can do restaurants spatially enabled data frame .shape. If you know pandas data frames, you know that .shape gives you kind of a brief little description. So we have 5,026 restaurants with 22 attributes. You can also do .describe. Pretty much all the data frame operations are available through the spatially enabled data frame, but you have access to quite a few more. And then right over here, we get our first map. So I'm making a restaurants map. I'm passing it Pittsburgh to geocode it. And then the second line is really powerful. This is the restaurants spatially enabled data frame, .spatial.plot, and I'm passing it a map widget as an input, the restaurants map that we just created. So it's taking the data straight from the spatially enabled data frame, plotting it, and that's a quick way to kind of visualize your content. So then over here, I'm going to go ahead and make use of our little helper function that we made earlier, the create map and histogram, and we're going to pass it Pittsburgh as the map that we want to create the location for the map. The restaurant spatially enabled data frame as the data, and there's a column in there called sales volume. And we're going to get out of that a restaurant's map and a sales histogram. Let's go ahead and make the call to the map. So there's our map, and then let's show our sales histogram. There we go. So most restaurants don't make, there's basically quite a few restaurants that make about 0 to maybe somewhere around $3 million per year. And then there's kind of a few restaurants that make a lot of money. With Bokeh, you could zoom in and kind of make this an interactive chart and get quite a bit closer and see those really, really rich restaurants. So this is just kind of a quick little way to kind of start working with both maps and charts. But maybe you want to start asking some questions. What are the top 5 restaurants by sales volume, perhaps? So over here, what we're doing is just really working with that spatially enabled data frame and working with how it sorts, group buys, et cetera. In this case, what I want to do is basically make another subset of the restaurant's data frame. And I'm going to use that sort values. And I'm going to sort by the sales volume using ascending equals false. What that means is we're just going to sort by a column, right? And then that gives me essentially the top 5. It looks like people really like their Cheesecake Factory in Pittsburgh. And actually, Cheesecake Factory seems to be just the restaurant analysis destroyer everywhere in the United States. So that could be an outlier that we may remove later. But if we want to take a look at basically a chart of their sales volumes, you see that Cheesecake Factory has about 14 million per year, and then the other ones aren't too far behind. What was cool is that we redid this analysis, just plugged in Washington, D.C. data. Cheesecake Factory was number 3 in that case. But like the number 1 was like this fancy restaurant in Georgetown, and you could kind of quickly replicate some of the sequence there. So let's make a map of those 5 restaurants. We made a subset of that restaurant's spatially enabled data frame. As another spatially enabled data frame, I can quickly just plot those 5 records. So then, maybe we want to get the zip codes. And in that case, you can use the ArcGIS API for Python to query the geometry engine, get the zip code geometries. Maybe you have an attribute that says zip code, and make a quick map of those zip codes if that's something that you wanted to do. In this case, I'm actually just going to quickly take a look at those zip codes that have the total highest sales volume, but actually, or the average sales volume that is the highest. But actually, what I want to get into is performing spatial analysis. So the first tool that we're going to use is fine point clusters, which is based on density-based clustering. And density-based clustering is kind of 3 tools packaged into one. It finds clusters that either you really defined, or it uses a machine learning algorithm called HDV-scan if you don't really know a definition of a cluster. That can be really useful, for instance, if you have dense urban areas or sparse rural areas, and you don't really want to think about the definition of a cluster in both of those contexts. You just want to let the tool decide a definition of a cluster for each region of your study area. And that's actually quite useful here. So the way we do it is This example already has it all written out, but perhaps you may not know how to invoke these functions. So take a look at the second option, analysis, because it gives you access to all of those analysis tools that Rohit mentioned in the beginning. And over here specifically, I'm going to take a look at analyze patterns, find point clusters. So you can add that cell. It'll create that cell with the right call to the tool for you, features that analyze patterns that find point clusters. In this case, I'm just going to execute what we already have. So let's take a look at that. It should just take a few seconds to execute. And actually, while that executes, let's go ahead and explain the next cell. We're going to get a clusters output. Oh, I already created it. I'm a dummy. Let's go ahead and rename it. And while that executes, we're going to create our map of Pittsburgh, our results map. We're going to add the layer called clusters output and simply visualize that map. And then we're also going to go ahead and get a spatially enabled data frame out of that output. So here's the output of find point clusters for all of those restaurants. So it looks a little bit like a Jackson Pollock painting, but really what it does is kind of gives you these, if you look at the original data set of all those points scattered about, it's kind of hard to figure out where to start. But this finds these meaningful kind of zones of a lot of restaurants. They kind of coincide with neighborhoods when we started looking at this closely, which was kind of neat. And really speaking, what we wanted to target is what neighborhoods should be prioritized. So that was a good start point. And in downtown Pittsburgh, these clusters are much packed together, much more dense. But if you look at kind of like the suburbs of Pittsburgh, like out by the big malls, where the cheesecake factories are, they're kind of a bit more sparse. And that makes sense. Like a context, like cluster in suburban Pittsburgh should be a little bit different than a cluster in downtown hipster Pittsburgh, right? And that's fine. We want to compare both of those in their own context. So continuing on, we're going to go ahead and get a clusters spatially enabled data frame out of that. The way you do that is pandas.dataframe.spatial.from layer, because we have our clusters output layer. So again, with data frames, you just have a lot of capabilities, and the spatially enabled data frame quickly lets you get it out of the output of an analysis. Now, the second part of this analysis, we have these clusters. So every restaurant has been labeled as part of a cluster or just noise. But really what we want to get to is these zones that can be the targets of further analysis. So in this case, there's another tool called directional distribution, or ellipses. And this is pretty useful in conjunction with density-based clustering, because you can pass it the cluster IDs as the item to group by, and it'll create an ellipse for each area. And it sounds simple, like it's just ellipses around the points or the clusters, but it actually does a lot behind the scenes. It calculates the central feature. It does a standard distance from that center feature to kind of measure dispersion of the cluster, et cetera. So let's take a look at the output of that. And I'm going to move a little bit faster here. So now what we've done is pass all the cluster IDs as an input to find to standard deviational ellipses, and we have all these zones. And then those zones are the targets of further analysis. So that's when we start to get into what are the most important ellipse zones that we should prioritize. And then you can start looking once again at the analysis tools here. There's a tool that summarizes your data. So over here, we're going to summarize two fields: sales volume, the sum of the sales volume for each zone, and also the average sales volume for each zone. So that can be a starting point for prioritization. But later on, I'm actually going to speed a little bit through this and let you explore in your own time, because that makes a bit more sense. But really what you kind of want to get creative with is, because you have all these different tools, you can bring basically hotspots from ArcPy, or perhaps some Python ecosystem tool, or perhaps some ArcGIS API for Python tool, and kind of get creative about how you want to craft your analysis, right? So over here, let's go ahead and spoil the surprise a little bit. I'm going to just execute most of these cells and get us to the final answer. Yeah. So let's go ahead and get our final analysis map. So in brief summary, what we've started to do is now for each zone, we have a lot of metrics. We have total sales volume, we have average sales volume. We're also running hotspots, and the degree by which each zone may contain statistically significant clustering of sales volume is also added to each zone. So right over here, we start to get into hotspots analysis. That's where it's running right now. And it's using features that analyze patterns that find hotspots, which once again you can run in, which you can find in analyze patterns right here, find hotspots. So in this case, this is another type of clustering. So we're trying to cross-validate a little bit. It's not just the restaurant locations, but also the degree of clustering of sales volume. So you have these hotspot areas. Basically, it looks like north, south, east, west of Pittsburgh. And it's kind of interesting. They have these gigantic malls at those regions. So the sales volume is actually quite high, presumably because of Cheesecake Factory. So perhaps you can take this example and evaluate how to eliminate those outliers. And then the degree of clustering is now also given to the zones as another factor to prioritize by. And then the final answer really is this cross-validation and this scoring that starts to happen based on all of those factors. So let's take a look at those final zones. They actually pretty much coincided with those north, south, east, west areas. So the first one is actually over here. This is a very large mall. And this could be like a target for further analysis depending on the type of restaurant that you're looking to establish. That could be one start point. And really, I'll let you guys explore, but the final piece here is to present the results. The ArcGIS API for Python lets you create web maps out of your map widgets, which is something really useful to get your data back out of the notebook and present it. So right over here, we have our final web map that gives you those answers. So let's go ahead and open that, and then I'll hand it back over to Rohit. There we go. So there's our analysis, and we haven't filtered it for the top 5% or anything like that, but we can let people kind of explore at their own leisure. So now I'm going to hand it back to Rohit.
Awesome, thank you, Alberto. So that was a very comprehensive analysis. What's great about Notebook is not only can I see when I'm reviewing Alberto's notebook, like what he did to arrive at these outcomes, I could modify them, do the analysis on my city. I could use the notebook as a sort of a model that when I just run it, it gives me these information products like web maps that get, that I could serve out to the stakeholders. So now let's look at some other capabilities. Geocoding is very important. It's about taking a text address and plotting it on a map. Now, as Python developers, we've tried to make it as boring for you as possible. All you need to do is you just pass in a string, which is your address, like in this case, a single line address, and you geocode it. And the results you get, that's the location. In this case, the results are here. This is where 380 New York Street is on a map. I've drawn it on a map. Now, these addresses need not be single line addresses. You can restrict them and have multi-field addresses. Geocoding also lets you do point of interest geocoding. So very important for me is where can I find my coffee? Where are all the Starbucks in a particular extent? It lets you do these things as well. You can geocode one address, or you could geocode a number of addresses. So the most appropriate data structure for a list of addresses is a Python list. It's as simple, just pass in a list. You'll get back the results as a list. That's simple. You can also do reverse geocoding. So if someone clicks on a map, you want to find the nearest address to it, you can pass in that location, that lat long, get the results back. So whether you want to geocode one address or you want to geocode 100, for which you'll use batch geocoding, or 1,000, we also give you the ability to geocode a lot of addresses, and that's using tools in the WebGIS. So we've added support for geocoding big data as well. Like if you want to geocode millions of addresses, we're going to talk about GeoAnalytics in some time, but one of the tools that's there is the ability to geocode big data as well. Now let's talk about GeoEnrichment. We briefly saw it as a capability in the spatial analysis tools in ArcGIS features, but if you want to really get into it, and that's something you want to get a lot of demographic and business data, not only can you get it for features or feature layers, you can get it for different types of inputs. You could get it for street addresses, you could get it for just geometries like points, lines, or polygons. What are the demographic variables around these geometries? Within drive times or service areas of those locations. And here's something interesting, you could even get it for named geographical areas. So I could say within California, San Bernardino County, Redlands. And it's got a very rich API to get, these sub-geographies interactively. So look at the guide for GeoEnrichment for that. You can also create reports. So these reports, you're just given your area of interest, and it'll create reports of demographic variables. So there is these tapestry variables where some interesting work has been done. Tapestry profiles have been created for containing information on these categories of people. Where do the young people live? Where do the high income groups live? And they've got these interesting names, like now you can see that in my area of interest, the young and restless, there are 27% of them, and 21% are set to impress. So well, these are tapestry profiles. That's interesting to even read about what categorizes that demographic profile. And you can get this and can use it for a lot of site selection, a lot of important categories. Now let's talk about network analysis. That's also available through the Python API. So you can do a lot of powerful things like creating simple routes or optimized routes for a number of destinations. You can do service area analysis. What are the areas that can be served within 15 minutes of this fire station, for example? You can do location allocation. So where should you create a clinic to cater to people with particular disabilities or diseases? What's the most optimum place for that? So a lot of these core GIS tasks where that were available in the desktop are now available in server, in online. You can take advantage of them. You can take advantage of live traffic information, those layers that are available in the Living Atlas as well. And if you're a UPS or a FedEx or a very, someone for whom routing is a very important capability, we've got tools to do that through the vehicle routing problem APIs accessible through the Python API. So here it's showing some service area analysis, plotting the different 5, 10, and 15-minute travel times from this facility if the mode of travel is trucks. And we've got these modes of travels. You can do it for walking, you can do it for driving using cars and things like that. Now let's look at raster and imagery. How many of you work with imagery and raster analysis? Okay, quite a lot of you. And it's, from a Python perspective, it's similar. These services on our web are just layers, and you can get their items in my WebGIS. I can search them. I just need to say the type is imagery layer in this case. And in this case, I'm using a multispectral Landsat layer. Now these layers are, you can take them, add them to a map. These layers also come with server-side raster functions that can be applied on these layers. So here we are looking at just the RGB, but there's like agriculture, there's a vegetation index, a lot of server-side raster functions. But you're not restricted to just using the server-side functions that the layer has been published with. We give you over 100 of these raster functions that you can use for the analysis that you want to do. That includes math operators. It includes data management and conversion, like remap, clipping, creating masks. You get functions for visualization, the stretch kind of percentage clip stretch you want to do, pan sharpening, interpolation, surface generation, and terrain analysis. And then a lot of these analysis functions, band arithmetic, NDVI, the different kinds of indices And if there's something specific that we don't provide you, and it's your algorithm that you want to bring in, we also give you the ability to create your own Python raster functions that work on the pixel data and do the analysis that you want to do. And you can create chains of these raster functions. These are like raster function templates. Just like you can create these raster function chains in Pro, in the Python API, you get a very Pythonic and a map algebraic way of doing that. So let's look at an example here. So here's an example of doing fire analysis using Landsat. And here we are just visualizing the before and after to see the damage that's caused by the fire. Here's a school that's been destroyed. These are from the 2017 Thomas fire, which at that time was the largest wildfire. Now every year the next wildfire becomes the largest, unfortunately. So we are getting the Landsat layer that we just saw, and these from that layer. I just searched for it, got my layer. And Landsat, as you know, keeps visiting the same place every 15 days or so. Here I'm just filtering the number of scenes that are available for a particular area of interest. That's my area, study area. And I'm getting the last two around Thomas fire, before the fire and after the fire. Now, once I get those variables representing those scenes, I can run this code, apply a server-side raster function. And this is showing a lot of smoke and haze. But since this is Landsat, we can use some of those bands that can see through some of that smoke and haze. And here we are getting this particular band combination, which is allows us to see through a lot of that smoke and haze and actually see some of the burning fires in that region. And for comparison, here's the same area from before the fires. Now, it might look like I'm just scrolling through a page with pretty pictures, but the notebook is a living and breathing document. So if I wanted to experiment with a different band combination, I can go ahead, change it, rerun that cell, and get entirely different results. And then here's what I was talking about. You can get functions like band arithmetic. So the analysis I'm doing is doing the normalized burn ratio and mapping them, categorizing it by the severity of the fire. So you can do band arithmetic. You can do map algebra, subtracting one raster from another, in this case, to get the difference in the burn index. And I'm using that to then compute the area consumed by the fire or find its distribution by severity. So these are some of the things you can do. So far, this was using on-the-fly raster processing, but using raster analytics, you can then do this analysis on the server. And all you need to do is, in this case, I'm calling two features on the burnt areas and creating a layer which contains the boundary of the fire. That's a feature layer that operates at the source resolution of my raster, not just the display resolution. So it needs a lot of computing power that the raster analytics servers in your enterprise provide you. And finally, we are doing some GeoEnrichment to get the number of people in the fire perimeter and plotting it using matplotlib. That's something else. You can bring in libraries from the data science ecosystem, do things like this. So we saw an example of the raster analysis. I'm going to skip through this other example that I had shown at plenary a couple years ago. Now let's talk about GeoAnalytics, which is big data analysis. So what it lets you do is do a similar set of operations that you saw with spatial analysis tools, like summarizing data, managing it, using proximity analysis. A lot of those tools, but taking care of the spatio-temporal aspects. We also, these tools are also time-aware. And it lives in the ArcGIS.geoAnalytics module. So let's now switch over to Alberto, who's going to show us another demo of GeoAnalytics.
Excellent. Thank you. And we'll make this demo very quick so that we can cover some stuff later. This one, I really just want to point you to another example in the gallery of notebooks, this one prepared for one of our colleagues, Adma Mani. And he details this process of data preparation, getting it ready for GeoAnalytics server. And this is for hurricane data. So the National Hurricane Center actually publishes hurricane track data all the way from the 1800s. If you follow along with this example, you can see that there's a way to download all of those files directly from their website through this notebook. But what's interesting is it uses something in Python called Dask. A Dask data frame lets you distribute tasks to different different files and different compute nodes. But really, the main point of this notebook is to kind of help you see how different Python modules can help you with data preparation. And then towards the end, I'm going to skip a lot of this. Let me see if we can visualize. Yeah, here it is. What we ended up doing with is, in summary, is downloading about 167 different CSVs with several thousand records each, treating them all as if they were a single data set using Dask, cleaning up all of those CSVs because they had header rows, multiple duplicate columns. You just basically pass one cleanup operation and it does it for all 167 CSVs. And then this graphic kind of visualizes all the different compute nodes that Dask creates for all of those cleanup operations for all the 167 files. But really, that's just a Python ecosystem thing. Then the important thing is that we get it back into a GIS format. And the point is to basically be able to work with GeoAnalytics to visualize the tracks of the hurricanes and do some pattern analysis. So for the sake of time, I'm actually going to hand it back to Rohit to cover some of the rest of the content.
Sure. Thank you, Alberto. One moment.
You're 3, right?
5. Okay, so now let's look at another module for deep learning. We've added a new module to the Python API. It's called ArcGIS Learn. It's inspired by scikit-learn. How many of you have heard of scikit-learn? A lot of you. And you know how in Python, scikit-learn really simplifies using machine learning in your workflows. So our goal with ArcGIS Learn is to do the same for geospatial deep learning. And with ArcGIS Learn, you can now do the entire gamut of things that are possible with deep learning within the ArcGIS ecosystem. So not only can you work with imagery, get it from our Living Atlas, or add your own imagery, you can prepare it, you can now even in Pro, you might have seen tools like the export training data for deep learning. They are available in image server as well. With this library and ArcGIS notebooks that has all the dependencies built in, you can easily train deep learning models on your data in 3 to 5 lines of code. This used to take, if you're using TensorFlow or another library which is not built for GIS, it can take dozens of lines of code, and the hard part is even installing all of those dependencies. So with ArcGIS notebooks and this library, we make it dead simple to do that. Finally, once you've trained your model, the same model can be deployed in ArcGIS Pro or ArcGIS Enterprise with image server. You can do the inferencing at scale and then take the results out to the field using our apps. And it's not just about training. It starts from exporting your training data to training the different types of deep learning models. You might want to do pixel classification. You might want to do object detection. Or you might just simply want to do image classification, in which you want to differentiate between burnt houses and houses that are not damaged after a fire. That's the USAA demo that you saw at the plenary. That was done using ArcGIS Learn. You can do data augmentation, so randomly zooming, flipping, and rotating those images and giving more variety to your model to learn from. You can manage the deployment of your model, and of course, you can do inferencing at scale. And these are the kinds of things that are possible today with ArcGIS Learn. Damage structure identification, you saw that. The second example is of finding the building footprints. You could do land cover classification as well. A lot of these examples that you have seen. So let's actually see this through some examples. Here's a notebook that's showing how USAA, that demo that you saw at the plenary, was able to do finding houses that were damaged after a fire. So after taking those exported chips from ArcGIS Pro, which contain some labeled data, someone has manually marked about a few hundred of these houses as damaged or not damaged, used ArcGIS Pro to export those chips that are used to train the model. With the arcgis.learn module, I can bring those chips in the notebook, do some random augmentations on them, and this is what they look like after performing those augmentations. And then it's time to train our model. Here we are. Yes, you had a question?
Is it self-learning for classifying damaged and undamaged, or I should give a feedback to enhance the machine?
So the question is does it learn, or you have to give, okay, whether it just learns from looking at the data, or you need to give some feedback in between? So it's just data driven, and by looking at a lot of these examples, like hundreds of these examples over and over again, the model learns to differentiate between damaged and undamaged in this example by itself. So here we are just pointing at that data. Okay, it's insisting to show that on the screen, but let's just move ahead with the demo. Okay, I'm choosing you. Thank you. Okay, so I'm creating my classifier, and we give you tools like finding the optimum learning rate, which is an important parameter when training your model. It lets you choose the right rate of training, otherwise your model will either be too slow to learn or will fail to learn. And we make it very simple. Once you have the right learning rate, you just train it over several iterations, giving that learning rate. And as you can see, with 10 training epochs, we reach an accuracy of 99%. And I'm not surprised by this, because really in deep learning, image classification is a solved problem. It's now better than humans at doing simple tasks like these. And here are some results of which houses are categorized as damaged and undamaged. On the top, you've got the ground truth, and on the bottom, you've got the predictions. So when we take this model, we can then save it out, and it creates an EMD model definition file that you can then use for inferencing. In this case, I'm also doing the inferencing and finding those damaged buildings using Python code. And here are the results. It's a web map showing the damaged buildings in red, and green is the undamaged buildings. And we did this over a large area for the Woolsey fires. So that's how you can take this manual, labor-intensive process, do it very quickly. Now let's switch over to this virtual machine where I'm trying to do another problem, which is pixel classification. And I'll do it live, so you know how easy it is and how quickly, with a small set of data, you can actually train a model and it can learn. So we are just looking at land cover classification. It's showing the major roads as black, the buildings as red, and the grass areas as green. I've created a classifier. Let's look at what it's learned so far. In this case, my model is a UNet classifier. And on the left is the ground truth. On the right is the predictions. And you can see how it's just giving garbage results. It doesn't know anything yet, because we haven't trained the model. It hasn't looked at the data yet. And here I've already run the learning rate finder, so I'm going to pick that and train my model for 10 epochs over a small set of that data. For this example, I'm only using 50 chips, so I can show how we can do it live, interactively in front of you. And as I'm talking, this, it's going through each of those 50 chips and learning from this data. The accuracy is going up and down, as you can see. Now it's reached, it started with 76%, went down to 37 while it was learning. It maybe learned something wrong. but it's finally figured its way out, and now it's closing to 87 or 84%. So once I've trained that model, this is the results from the earlier iteration. This line of code takes a little bit of time to run. Let me just run it anyway. So you'll see how it's learned the major classes of the land cover. So while I run that and we see the results later on, I can, in the next step, save out that model. And by training it further or giving it more data, I get better convergence, reduce the accuracy, and I start getting excellent results like finding the actual buildings as well. Let's see if those results came up. It's still running that, and we are a little short of time, but you've seen that as well. And then finally, you can take that model definition and just simply pass that in the Classify Pixels tool and get your results. Let's keep moving and see what else we've got. We've seen that. Here's another example of detecting building footprints using a similar workflow. Let's just look at some of the results that we got. And this, is showing the results of a building footprints model. And when we saw this result, it has not needed any hand editing. All of us, we're just looking at what deep learning can do, and it's amazing that it was able to come up with these kinds of building footprints. There are post-processing tools in ArcGIS that let you regularize an irregular footprint, and you just give it some rules that buildings are mostly right angles, but when you need to go at a diagonal, this is the penalty you need to give. Just by tweaking those parameters, here are some of the results that we got. We actually did it for all of this region affected by the fire, around 60,000 buildings. And when we did it in ArcGIS Pro using a previous generation GPU, which we had, it took about 4.5 hours. So that's fine, but you can then scale it up or scale it out. You can get better GPUs, or you can add more servers with image server. And we were able to get it down to creating in 20 minutes, creating these 60,000 building footprints. That's a rate of 3,000 footprints per minute. And imagine how a task like this used to take earlier, or still takes, when people are manually digitizing them by hand. So here are some resources. If you want to take a picture, this will help you get started with ArcGIS.learn. We've got a blog post, and on medium.com/GeoAI, that's where our deep learning blog posts are. A lot of examples that you can see there. And we've got some examples of how you can do pixel classification and object detection as well. So we already seen the spatial data frame. We are not going to go into that. It's like Alberto talked about that. It's a great way to go from ArcGIS into the other libraries. And talking about data science with ArcGIS, you get a wide variety of data sets, Esri content from the Living Atlas, your content, partner content. You get the visualization capabilities. You saw the map and the widgets. You get that from ArcGIS. You also get that from the open source ecosystem. You get the different analysis engines. We went through a lot of them. And of course, you can bring in analysis from your Python libraries like Pandas or scikit-learn, TensorFlow, PyTorch. So it's a great platform for doing your analysis. Finally, once you've done that, Python is also a great way to then deploy your results. You can share them using ArcGIS through web maps or story maps, web scenes. You can deploy them as dashboards. So with that, we've come up to the conclusion of this session. We do have 2 minutes. I do request you to please give your feedback so we can do a better job next time. And
we read every entry, and that helps us really refine this content. So
yes,
we really appreciate it if you do.
Yeah, it's very important for us, and this content is actually in response to what feedback we received earlier. So we are open for questions for a couple minutes, and yeah.
Does the notebook server have any, what's the licensing or any dependencies associated with it?
Yes. Does Notebook Server have any licensing or additional dependencies for it? So there are two licenses. There's standard and advanced. Standard comes with ArcGIS Enterprise at no extra cost. The only difference between standard and advanced is the ability to use ArcPy. And then advanced, the cost, yeah, we probably can talk in the ArcGIS Notebook Island if you have specific questions, because I'm actually, off the top of my head, I'm not sure what the licensing cost is at that point.
Okay, before we go to the next question, for those of you who are patient enough, these were the results before training. We did get the results after training, so you can see how at least the major classes of land use, it's been able to figure out in under a minute with 50 chips. So it's really approachable and it does work. Question there.
So when you create a web map in a notebook, is there any way to link to the notebooks, the metadata or anything like that?
From the web map?
Yeah.
When you create a web map from the notebook, is there any way to link back to the notebook from the web map? There's no automated way that says this web map was created in this notebook, but that's an interesting question. Right now, I would suppose you can add it to like the metadata of the web map. Maybe as you're creating the web map, in the description of the web map, you can create a link to the URL of the notebook or to the notebook item. But right now, it would be manual. Yeah. Yes.
Does geocoding still cost credits?
Geocoding does cost credits. That's, yeah, correct.
If you're doing it on ArcGIS Online, yeah. If you're doing it on premises, it doesn't. So.
Yeah, correct. Yeah. Yes.
When you create a learning instance, where does that stay? Is it an item on ArcGIS so that you, like for building footprints, if I run it on aerial imagery now and then new developments come in, does it still live there, or do I have to retrain and run the code in the notebook again?
Okay, so the question is that when you train a model, and let's say you get building footprints, I like where does it stay? Does it persist? And like as you get new imagery, how do you get new results, right? Is that correct? So yes, the models that you train are deep learning packages, and these are items in your WebGIS. You can save that model itself as an item, and it can be used with Pro at a later time. It could be used with notebooks at a later time. And the results that you get, the building footprints, for example, are feature layers, and they also live in your WebGIS. So as you get new imagery, you can rerun that model on the new imagery and get newer, updated results. You had a question?
What's the spatial resolution of those images that you're training to?
Okay, so the question is, what's the spatial resolution? In this case, we used a spatial resolution of 1 meter. The data for this land cover classification is coming from the Chesapeake Conservancy Project, and they did 1 meter resolution data, and we use that for training. The other example that I showed for the building damage classification, that was very high resolution drone imagery. I think it was 3 centimeters or some very high resolution imagery.
So does it work with Landsat?
Does it work with Landsat? Yes, there is there was an example with Sentinel that Vinay had done for finding well paths. So yes, if the feature of interest that you want to identify, or you want to, if you want to do object detection and that feature is big enough to show in that resolution, it will work. If you're just doing, like, let's say, pixel classification and your labels are at that resolution, it will work. It'll learn at that resolution. Correct. There's a question there?
So if you bring in a second set of training data, would it start all over, or would you return the first set of training?
Yeah, that's an excellent question. Let's say you already trained your model on some data, and now you have more data to train on. Do you start from scratch with all the data, or can you take the model that you trained earlier and improve it further? We allow you to take a trained model and create these classifiers or object detectors by loading in the model that you trained earlier. And you can further fine tune or train it further with more data. So yes, it is an important use case and it is handled. Correct. Sure.
Maybe one more question? Okay.
Okay.
Maybe not. Thank you
you.
everyone so much.